So what is Rust? Rust is a systems programming language. It is often compared superficially to Go. There's kind of two types of people who discuss Rust and Go. There's the people who understand each language's target applications, and then there's the people who think they're competitors. Go is a language for sysadmins. Rust is a language for systems-level programming. Rust has a high priority on safety and performance. So if you've ever managed memory before, you'll know that it's easy to make mistakes. And the other very salient feature of Rust is it has a unique and somewhat famous community. We have a strong code of conduct that says, thou shalt be constructive, thou shalt not be a jerk, and here is what we will do and how we will remind you not to and then remove you if you continue. This makes it controversial among the people who don't want to work in a moderated, constructive community. So the buzzwords that you'll hear around Rust are pursuing the trifecta of safety, speed, and concurrency. I find that a little funny because easy concurrency falls out of the safety priorities that Rust has. Rust pursues memory safety without garbage collection, prioritizes zero-cost abstractions, and the real motto is hack without fear. If you're not totally comfortable with this whole memory safety and garbage collection thing, the long story short is that your computer has a bunch of spaces where it can store little bits of information and get back to it fast. And since these are finite, you need to reuse them at some point. If you mess up in reusing them, you try to reuse it too soon, you leave something there that you shouldn't have, all kinds of problems ensue. Various languages have various approaches to preventing these problems. C and other low-level languages basically say, here are the principles to how to do it right. You're smart, follow those principles. Oh, what's that? Your code base is tens of thousands of lines long and you're accessing the same piece of memory from 14 different places. Oh, just keep following the rules. You're smart, you can do it. Many interpreted languages use garbage collection. They say, no, I'm just going to stop when we need more memory or at a certain time, pause for a moment, go through all of the memory, and sort things out the way they should be. This creates a pause that can be noticeable on lower performance devices, and so Rust doesn't consider that an acceptable solution. Whereas Rust addresses the problem of memory management by mathematically proving the correctness of the program at compile time. It uses the abstractions that we'll talk about throughout this talk to guarantee that it's impossible for the program to break those rules that older languages say, yeah, you should just know it and just do it yourself. A bit of history on Rust. The language has been around since sometime in 2010. I don't know how long Graydon was thinking about that beforehand. It was really based on a lifetime of experience from the many compiler authors. Rust 1.0 stable was released in May 2015. So the stable Rust is hitting about 2 years old. We're currently up to version 1.14.0. This is, we release a new stable version every 6 weeks. And Rust 2.0 would be a breaking change backwards, so that is not on the roadmap. The number will just keep going up in the middle there. And Rust is a project that was originated by a Mozillian when he was working at Mozilla. Many of the core team and Rust team members are employed by Mozilla, but it's strictly a sponsorship and support relationship. If, let's say, the CEO of Mozilla decided, hey, Rust needs green threads again, and tried to tell them to, they'd be like, you can submit an RFC and we can discuss it, but no. So it is not owned by any particular company. It is owned by the group of contributors to it. Some projects written in Rust that you might have heard about. The Servo browser engine is also being developed within Mozilla to improve Firefox's performance ultimately. And Jack gave a fantastic talk about that yesterday, so you can pull up that recording. The Chef guys have recently released Habitat, which is, I'm just going to say infrastructure tooling, because if I try to be more specific, I will get but it can also do that other thing, as many infrastructure tooling systems tend to be. Dropbox uses Rust quite a bit internally. I find that interesting because they considered a variety of recent languages, what's cool to play with, and they picked Rust for its performance. And if you want to see more projects that use Rust, check out the Friends page. If your company is betting money on Rust, using Rust in production at some point, and isn't on that Friends page, pull requests are welcome. You can help us fix that. So Under what circumstances should you use Rest? Speed and safety are critical. We'll set it above any old scripting language. If you're targeting any architecture that LLVM supports, you will have a pretty straightforward time getting Rest on it if that support isn't there already. If not, you may be better off waiting for LLVM or working on that support first, because we take advantage of a variety of the speedups that LLVM has learned to use over the years. And if your team likes learning new technology. I see a lot of companies using Rest almost as a reward for their engineers because they get a shiny new toy, as it were. And the obligatory, when might you not want to use Rest? If you're on a heck of a deadline and you don't have time to go spend a few months learning a new language and getting comfortable with it, Rest is probably not a good thing to adopt. If you need to reuse giant chunks of code that's written in another language, Rest may or may not be appropriate. There are a variety of efforts to work on porting other code to Rest and interfacing between Rest and other code. You can hear about the state of some of them on Friday at 1:20 in Tasman, BC. And if your company or people on your team are just not willing to abide by the Rest community's code of conduct, they're going to have a very unpleasant experience trying to get help. So those are kind of unusual, but Rest may not always be the right answer for you. So any questions at the moment about Rest's place in the world and what's going on here? Nope, cool. Yeah?
The star about corrode, the last time I looked at corrode, it had a big disclaimer on Demi's page about can translate some C programs, probably not any.
Yes, yes, there is a footnote about mentioning corrode. It cannot translate all C yet, but it translates some C, and it is under active involvement and sponsored by a Mozilla grant. He has successfully translated CVS in a way that passes the tests. Because there's an awful lot of code that lives in CVS. So now let's talk about getting Rest running. How are we doing on time? We are doing excellently on time. So Rest comes out in 3 different channels. There is nightly, which we try to release every night. Every once in a while, a nightly will fail because some change got introduced that doesn't quite build somewhere, although we attempt to prevent that. And nightly is where we try cool new ideas that have made it through the request for comment process. Not all features in nightly make it to stable, and a feature can often live in nightly for a very long time before we figure out the story for how it should be stabilized. There's the beta channel that you will see when you're given an option to download various artifacts, which are release candidates for stable. I don't know of any project that chooses beta and is like, let's pin ourselves to beta as opposed to just using the stable that's out. And the stable versions of Rest, we promise, will always be backwards compatible. You can check out the Rest 1.0 release blog there in the footnote for the details on that, but we bend over backwards to try to make sure that no stable will break code that worked in the last one. So which channel should you be using? It depends on the project. Stable code should run on any beta and pretty much should run on any nightly, although nightlies are a little bit Wild West. There may be temporarily a bug in a nightly that keeps your stable code from running on it. Generally, when in doubt, pick stable. Go as far as you can with stable, and you will probably eventually run into a compelling reason to use nightly if you need some feature that's not yet stabilized, if you need to pull in a dependency that requires nightly, and so forth. But you'll know when it's time because suddenly things will stop working. And all of the code that you've written on stable will just keep working transparently. So you will know when it's time to make that switch. But if you can write your library in only stable Rest, that's a really good practice. So I said that we make a great effort to make sure that no stable breaks the code that ran on the previous one. One of the ways that we do that is with a fantastic tool that Brian Anderson wrote called Crater. And what Crater does is it finds all of the Rest code that we know about. We define this as all of the publicly published libraries of Rest code. And it tries to compile them all with the old stable, and it tries to compile them all with the new stable candidate. And then we compare the results. If there used to be a warning and now there isn't, something's wrong. we've got to make sure that was an intentional change. If there used to be no warnings and now there are some, we got to make sure that was an intentional change. And so you will sometimes see pull requests from the core team out to various libraries going, hey, we needed to change a thing in stable. This fixes what would otherwise have broken. So if it's possible to have your code public, that is a major benefit of doing so. And you can view the source of Crater and contribute to its development or borrow the idea for your own project from that URL there. So any questions about channels before we move on to how you get a Rust installed? Yeah, it's pretty, we've got one question there. I will really, let's.
Do you register your code and say, I'm publishing something in Rust, or do you go out searching for it?
I will talk about how to publish to our crates index when we talk about cargo and about how to depend on libraries. So we will get to that. Moving on to how do I get a Rust? There are a variety of ways depending on what you want to do with it. If you just want to play around with Rust, we have a tool called the Playpen, of which there are 2 major deployments available to you at the moment. There is play.integer32.com that lets you use a variety of the top 50, I think, popular libraries. And there's also play.rustlang.org that lets you have a slightly different set of features. You can see the intermediate representation that you can't see on play.integer32. But as you're starting out, they're pretty much equivalent. If all you want to do is have a little REPL, have a hello world kind of thing, play with syntax, then the Playpens are probably what you want. If you want several versions on a machine, if you're going to be running some things on nightly and some things on stable, for instance, or you want to test with a couple of different stable versions for some reason, you want Restup. Restup.rs is both the name of a Rust script and the URL to which you can go to get the installation instructions for said Rust script. Then another option is a system package manager. Not all systems have Rust packaged for them. You can add it to your favorite if they accept contributions. If you want to know more about Rust and package managers and the conflict between package managers and libraries, check out the talk at 3:40 p.m. today in Tasman A about all of that. And if you're extremely concerned about security, vetting your code, you always have the option to compile yourself a Rust from source. So the Playpens, you can view their source, change it if you so desire. You have a variety of options. You can pick what you want, what output you want to get. Rather than just running the code, you can also see what assembly it actually compiled into that then got run, or what LLVM intermediate representation it went through to get to that assembly. So if you're tracking down a performance problem, these output options can be quite nice. Probably the best feature of the Playpens, other than not having to install anything on your local machine, is that there's a big old gist button. And when you click that, it pastes all of your code into a GitHub gist. And then you can just drop that link into a channel, an IRC channel, a Slack channel, wherever you're asking people for help. And they can click on it and be taken to exactly what you saw at the time you clicked that gist button in the Playpen, make changes, run it, short link it back to you, and you can collaborate quite easily on code in that way. There's, on integer 32, there's also a config button where you can pick your favorite editor behavior. Do you want your vi key bindings? Do you want your Emacs key bindings? Do you want it to act like the GitHub editor? And so forth, if editing text in a web interface tends to frustrate you. So the next option for getting Rust on your system, recommended way, is Restup. You can pull out all of the Restup docs there, but basically you just run the install script and it downloads the appropriate Rusts, it downloads Restup, checks that the signatures are right and so forth, and then installs it for you. It will put everything by default in your homedir.cargo bin. So it's not really digging around on your system, which may or may not be desired behavior. You can customize that if you want. And then once you've got Restup, it manages your Rusts for you. So you want some nightly Rust, you say Restup install nightly, and then you can say Restup run nightly, and then whatever you want to run. You can alias these commands to get them shorter, and you can set defaults within Restup. Like, usually I want stable, but I might want to invoke nightly sometimes, so you'd set the Restup default stable. And in terms of security, there is a bit of pushback on curling a script, which is a fair complaint to have. We GPG sign all of our releases, and the script check those signatures. That key that signs the releases that we distribute is held only by a couple of core team members who are very responsible with it. We do have authentication to Keybase IO because that is one of the more popular ways to check if a key belongs to who they say it does. We proved that by local signing. Don't worry, we're not the kinds of people who will ever send the private key over the network. As I said, Restup will check your signatures, and if you're going from source, you can just pull it from the GitHub repo and read the entire history to see if you like what you see, if you have that kind of time, and that's the way your priorities work out. So let's say that you've found a Rust project, you've installed Rust, and you're deploying the Rust code. The simple story there is you check the README for any funny system dependencies. Sometimes if it's using a wrapper for something that your system package manager might provide, they'll say, hey, you need these libraries available. You need such and such devel for this to work. Make sure you've got those first. And then you clone your project, CD into it, and cargo run. And when you tell cargo to run your code, it will look at the manifest and download any dependencies you need. It will download those dependencies and compile them. And then it will execute the main function if it's a binary project. We'll go into more detail about how to use cargo later on. For now, just trust me that the magic words to make the Rust go are cargo run. So questions about installation, when, what method is suitable? Let's see. No questions there. Hooray, I covered the content quite successfully. So now let's talk about the basics to writing Rust. There is a lot of new stuff and a lot of new combinations of old topics when it comes to writing Rust code. So I don't expect anybody to get it in a day. You will still be hitting weird errors months in. You will still make the occasional mistake and be told off by the compiler if you're one of the people who wrote the compiler. So when you're setting up to write Rust, maybe you're old school and you just pop open your text editor and know what you're doing and remember all the names of your functions. That's cool. You're awesome. But if you like tab completion and you like being told about your errors as you introduce them, we have IDE support in progress. You can check out Jonathan Turner's blog for the Rust language server, which is a thing that IDEs can hook into to get faster feedback about what's going on under the hood in Rust. And the canonical source of information about which IDEs support what for Rust is areweyet.com. It'll show you a matrix of all of the different IDEs that we're trying to support and what they have and what they haven't got. So pick your favorite, pick what's familiar, pick something new based on the features it has, or you can work on adding Rust support using the Rust language server to whatever IDE we don't have in that list yet. A common question is, does Rust have a REPL? Does C have a REPL? That's kind of weird. That's kind of a weird question for a compiled systems language. However, if you want that fast feedback on how your code is doing, in addition to using an editor with good support from the Rust language server, I personally use the Playpen. It's very quick and easy to make your edits, hit the run button, get your error. Your error will be a link to the docs on that error, as I will go into in more detail in just a moment. And then you can figure out why it happened and fix it. If you're just on IRC in one of the Rust channels that has Playbot in it, and you want to show somebody a quick example, you can tell Playbot a line of Rust that compiles and executes on its own. Playbot will run that for you and put the result back in the channel. And there have been efforts to build a proper REPL. That is, I think, the one that got the furthest to my knowledge, and it requires a specific nightly version no older than a certain date. So it may or may not be what you're looking for there. The thing to think about when Rust gives you an error, which it will do frequently when you're learning the language, is that The compiler wants to see your code do things right. Rust wants you to succeed. My mental image of it is that you're apprenticing under some really knowledgeable old hacker who worked on like mainframes in the 70s. And they're going to tell you, hey, I know this works right now, but it's going to get you in trouble later. Oh, that's a bad idea. That could get you in trouble in a bit. You shouldn't do that. You need to fix it now. And so the borrow checker and the compiler will give you a lot of that kind of feedback. But remember that it's because we don't want your code to have memory leaks, memory misuse, security holes. So the rules that the compiler enforces catch things that look like they're bad ideas. If you imagine the set of all possible programs that are correct, that don't misuse their memory, the set of all programs that most compilers will accept is way outside of that. They'll let you run any kind of thing that crashes, that misbehaves. And the set of programs that the Rust compiler will accept is just barely inside all the correct programs. There are a tiny number of correct programs that the Rust compiler won't let you compile because it doesn't know how to prove their correctness yet. When you find one of those, you can file a bug, and you can improve it. But usually, when you think you've found one of those, it was actually a bug in your code that the compiler caught for you. It's been getting better and better at that over the years because we fix it every time we find a little piece of its ignorance. So if you want to get around some of the rules about safety, you can write unsafe Rust. All I'm going to tell you about unsafe Rust today is that when you think you need it, you probably don't at first. You should probably hop into a chat channel with some more expert Rust users and ask them, hey, does this really have to be unsafe? How can I do this in a way that uses safe Rust? And then you will find eventually when you get into applications where you do need it. But if you see an unsafe block in a Rust program that you're assessing, that's your cue to look very, very hard at it because somebody thought they were smarter than the compiler. And I'm sorry, but this is a pretty rare occurrence. And then errors, we think that the errors deserve good documentation. As I mentioned, if you're using the Playpen and you get an error, it will tell you the error number, and that error number is a link. And so you click on the error number, and it says, this usually happens when these common circumstances, here's how to fix it. So if that error documentation is totally misleading, totally wrong, please file an issue and help us make it better, because we are working on it all the time to make it useful to you as the user. And yes, click on the error number in the Playpen. So if you think you got an error that you shouldn't have gotten, first search for that error. There will probably be several people on Stack Overflow, on a forum somewhere, on the Rust forums that we use as mailing lists saying, hey, I'm getting this error, or on the GitHub issues. I think the compiler's wrong. Here's my code, and the code looks a bit like yours. And then the answers say, no, here's how you fix your code so it's fine. And apply that fix, see if it fixes it for you. Drop your code in some paste bin and ask around on IRC. There are friendly experts who know about the compiler's guts, who can tell you what's happening and why. And if it turns out that you actually found something that the compiler was ignorant about, please, please file a bug. It's the only way we're going to get better. So there are a variety of other helpful tools to make your code more usable, better formatted, more readable, and easier to collaborate on. The two big ones are Rust format, which there should be a button for in the integer 32 Playpen, which you push the button and it formats your code according to Rust standards. If you don't have strong opinions about how your code should be formatted, please use Rust format. It will have strong opinions for you, and everyone will find your code quite easy. If you have a really rigorous standard style that doesn't quite match, you can configure Rust format to some extent and run it locally to make sure that all of the files in your project at least have consistent formatting. And also Clippy. Remember back in the day when you'd use a certain company's product, you'd have the little paperclip? Yeah, Clippy is kind of that, but for Rust and hopefully more helpful. Less weird googly eyes, too. So you run Clippy, as you can push the button in the Playpen, or invoke Clippy as described in the README of the docs. And Clippy will tell you, hey, I think this might not be as good as it could be. Here's where, here's where, here's where. You could make this better, you know. You could be using that other syntax for this that I think is easier to read. And so Clippy is another sort of automated piece of mentorship that will help you write rustier code. So any questions about errors, the fact that errors like you and want you to succeed, and that tooling? We've got one back there and one over there. I'm really putting my microphone runner through his paces. Could you raise, there you go.
With regard to the development environment, can you run it in an isolated network? It seems like if I'm getting errors, I'm needing to click on these links and go off. Can I maybe host those internally and run those too?
You can run Rust offline. If you're depending on various packages, you will need to get those packages into the network at some point. Cargo has an option to say error if you wanted to hit the network, so it'll tell you what it needs. And you can absolutely run Rust format, run Clippy, and then just search for that error code in a copy of the docs that stands alone. So you could happily write Rust on an airplane when the Wi-Fi is not working.
I'm guessing a lot of other people are playing on Rust, play.rustlang.org. I can't see Clippy anywhere. I don't know what you mean by that.
They have only deployed Clippy to the play.integer32.com playpen, which...
Sorry, you did say that.
Yep, I did. It was a brief soundbite in a wall of other relevant soundbites. I don't blame you for missing it. Any other questions about errors, playpens, Clippy, anything up to this point? We've got one more up here.
How far does the fact that you probably don't need unsafe Rust extend? Does that extend to if you're talking to hardware or to system libraries in C or things like that?
Excellent question. Those are the exceptions. You cannot prove the safety of anything outside of Rust. It's almost like the I/O conundrum in Haskell in a way, where if you're interfacing with something that you can't prove is safe, that little bit needs to be unsafe. Get out of unsafe as soon as you can by sanitizing that data, performing whatever logic you need to return something that's known. And then you can get right back into your safe code and keep on going. But yes, you will find in crates like Mio the missing I/O libraries, which aren't actually missing because they exist, and they're quite good. You will find unsafe Rust used to talk to the things that we can't prove are safe. I see no more hands. Let's move on. So let's talk a bit about Rust syntax. This will feel pretty familiar to anyone who's written C or to some extent Java. The most important thing to pay attention to when you're reading Rust at first, that's a bit different from other languages, is going to be the scopes. Anytime you have a matched pair of curly braces, that is a scope. And scopes will be very useful when we talk about lifetimes. Scopes help determine when a value is available and what can be done with a given value at that time. Scopes can be nested. Something belonging to the inner scope does not also belongs to the outer scope, or something that's available in the outer scope is also available in the inner scope. Something that's available in the inner scope won't necessarily still be available after that scope ends. And as you start reading Rust code, pay close attention to what scope a variable comes into existence during, because generally that is as long as that value will be able to live. We'll get back to this in lifetimes, but as you read your code, I'll be pointing out the scopes to you because making mistakes with them is one of the things that will most trip you up. So you need to make functions. It's hard to program well without functions, impossible to program Rust well without having at least a main function. The simplest kind of function you can have just has function declaration, fn, its name, and then a scope in which things happen. But most of the functions in the real world will also have a type signature. So a simple type signature will have your function name, and then you provide it not only the names of the arguments that you're promising to pass, but also the types that you're promising to pass for those arguments. The types don't all have to be the same. Each arg can have a different type if you so desire. And then you will have an arrow, and then you will tell the type, if you're returning anything, of the result. If you try to fail to return when you promised you would provide a result of a given type, you'll get errors. If you try to return something when you said you wouldn't be returning anything, you will get errors. If you try to return something that is not the type you promised you would return, you will also get errors. This is because inconsistency between what you say your function is going to do and what it actually does is a great way to introduce all kinds of problems into your code, human reading the code problems as well as technical problems. And then once you've spelled out what your function takes in and what sort of thing your function will give back, you can then have a scope that contains the actual logic and stuff of the function. Think of the type signatures basically like Mad Libs. You just fill in those slots in the syntax what the name is, what the type is, what the next name is, what the next type is. And all functions will have at least fn, the name, and the scope. As we talk about traits, you can also generalize over types. You can say, well, it could be a 32-bit int or a 34-bit int, or really it could be anything that I can add or anything that I can divide. We will touch on that later on. So I'd like to introduce macros to you so that you have a passing acquaintance with them before we start diving into code, because the first question when you print hello world is, why is there an exclamation point in there? Macros are shorthand they're syntactic sugar for functions that take some variable number of arguments. Like the print line state macro can interpolate pretty much any number of things into the string that it's printing. So it doesn't make sense to have that as a function on its own. So you'll have macro name bang, and then the list of arguments in parentheses. You can read much more about it in the book. And you will mostly see print line a lot when you're just getting started and playing with examples. So here's a function. Have a number. Cool. The main function is what we'll run by default and in the playpen. You will say, we are printing. And then the string we're going to print, the pair of curly braces interpolates the first argument after that. If there had been a second pair of curlies, they would have interpolated the second argument and so forth. And the thing that we're going to print is going to be the result of calling have on 4. Have says, I will take a 32-bit integer, and I will give you back a 32-bit integer. And what I'm going to do with it is I'm going to give you back that over 2. Crazy simple. If you happen to paste or type this into a playpen and change nearly anything about it, you can break it in a number of interesting ways. If you claim that if you were to create a number that wasn't a 32-bit integer, and try to pass it in, it would say, no, you promised me you'd give me one of those, and you gave me something else. You lied. I don't like you. If you try to return a string from it, it will say, you promised me you'd give me a 32-bit int. You lied. I don't like you. So you really have to follow through on what you tell the compiler that you're going to do. And you'll notice that it figured out that I wanted that character 4 there to be a 32-bit integer, because it's pretty smart that way. It could actually have interpolated some of the function signature as well. It is possible in the compiler to sometimes figure that out from context. But the language will always demand that you spell it out, mostly for your own benefit, because it will remind every programmer who interacts with that function exactly how it's supposed to work.
Can I, ask
yes.
a question? Specific related to that, can I reply?
Yes, hop in.
Sorry. There we go. Sorry. So in the keynote yesterday about shutting down the Mozilla project.
Persona, yes.
Persona. They talked specifically about some functions returned null, 0, or Boolean false, and all of those 3 things had a meaning. You're saying that, this is just me guessing,
yes.
That's not possible at all. It is either an int, or it's going to be a bool, or it'll be nullable, I'm assuming?
So if I say in my function signature, arrow I32, that means that if I try to return anything except a 32-bit integer, it won't compile.
So is there a way to say is nullable as well? Or
yeah, I could have an option. I could say I will return an option type that can contain either something or something else. I could, which is basically maybe for the functional programmers. I could, when we talk about traits, I could say I will return any type that can be added or something, or that can be divided. And so traits give you a lot of power there. And generally, if your function is going to want to return one of 3 radically different things, why did you do that?
Anyway.
Yes. Rust will not make that easy for you. It will make it somewhat possible if you really mess around with options and argument lists. Like you could say, I will return you an array that has these types in it. And then you could work with that if you needed to. But honestly, please don't. Please just write good code. Please write code that's easy to reason about is what I mean by good in this case.
Thank you.
You're very welcome. So, punctuation matters a lot here. Expressions end with a semicolon, such as print line, and my return statement there. There is a special exception when you're returning something, in that if you wanted to remove both the return and the semicolon there, just say x/2. If you leave a bare expression that evaluates to the correct type at the end of a function, Rust will just say, oh, you meant to return that. Cool. So some people like this syntax. Other people prefer to be more explicit about the return. That's pretty much the only case in which an expression should not be ended with a semicolon. So spaces matter in that they separate tokens. The string I32 is not the same as I space 32 because you have to parse your code and it has to like work and you want to be able to type I's and 32s separately. And beyond separating tokens, the white space does not matter here. I apologize in advance to anyone who's used to reading Python like I am. That's just as good. It's just as terribly awful if you want to read it, but it does the same thing.
Next slide.
Next slide. So this might be a good opportunity to mention that you can somewhat obfuscate your Rust, and then someone else can run Rust format on it and deobfuscate it if they so desire. And if you really like doing terrible things with challenging to read programs or general underhandedness, the Rust community team is currently running a thing called the Underhanded Rust Competition, where you write a little web server that does salami slicing on credit card payments. It pretends to take a credit card payment, and if it can successfully funnel off a few fractions of a cent each time without us noticing that in reviewing the code, you can get neat prizes and international fame. So if that's up your alley, I would strongly recommend you check it out. Anyways, to continue on with the actual beginner talk that I'm giving here. Your control flow syntax will look pretty familiar compared to other languages. You can say if and then evaluate a thing, and then the thing in the scope will only go if the if was true. You can loop infinitely by just saying loop, and then it'll just run. You can say while some condition is met, you continue. You can do for loops with ranges. There is a substantial section of the book on ranges because you can express them in a variety of ways, as you'll find in the bottom links on that slide. And then what may or may not be familiar to you, probably you'll recognize it if you're from C. You might not recognize it and go, wow, I didn't know I needed that, but I really needed that if you're from Python, are match statements. I think it's really neat. You can match on a variable, and then rather than a bunch of nested conditionals, it will just go through line by line, and if it matches, then it will do whatever you told it to. So here I'll also introduce you to declaring a variable. We open the scope of main. We say let day equals 19. So we have day now owns the value of 19. We'll get back to that later. And then we can use it. We can use the value from it because day owns the value 19, so we can print it. And then we can match on it. We can say if day is 15, so that's the syntax for matching a single value. We can take some action. In this case, I'll print something cute. You can say if we match on any of these conditions in this list with the pipe to say or, then the action we're going to take is print a different cute thing. And we can also match on ranges. So the triple dot is an inclusive range, and you can say if it's anywhere in there, you can take this other action. Now finally, you can fall through and handle anything else. This is especially important if you promised you would give some value back. You'd better be giving back a value of that type. If there's any way your program can fail to give that value back, it won't compile. You can catch all other cases with the underscore, and then we can print whatever's appropriate in that case. So that's a simple example of matching in Rust. I think it's one of the cuter parts of just standard syntax before you start getting into the mind-bending bits. So questions about simple syntax stuff? We've got one over there already. Oh, well, say it and I'll repeat it.
True and false. Will Rust only consider true and false as true and false, or will it treat one as
True.
True and false. And there is a Boolean type. If you want a Boolean, make a Boolean of the Boolean type. You probably do not want to be coercing things to and from Boolean. You can just carry a bool around. So how are we doing? We have about 4 minutes until I said I would give you guys a 10-minute break, and we are right on schedule. At 25 past, we will break, so anybody who needs to hop into a talk in the next slot can sneak out. Anyone who wants to sneak in can, although if you have a seat here and want to keep it, I would strongly recommend hanging on to it. I'll take a few general questions about Rust, Mozilla, whatever interests you and you're wondering about while we fill that time. Well, still no microphone, but any other general questions? Yeah?
Why is it a crab?
Oh, fantastic question about the Rust community. Why is there a crab on my shirt? The answer to why there is a crab on my shirt, you can go to rustation.net, and there you will meet our mascot, unofficially, whose name is Faris. He is a Rustation. He's quite cute and useful for imagery if you're doing a talk, and useful for identifying other Rustations, which is what we call Rust users. Some people tried Rustafarian, but that didn't catch on the way Rustation did. It made the keynote about the lobsters really resonate with me when we talk about project maintainer treatment. So all of the Faris art is CC0. Do with it what you will. Send it to Spoonflower and print it on cloth and make a tablecloth. Tweet photos of it, and you will become famous in the Rust community. So plushies of him, I developed a pattern and released it for free. Do what you will with it. Also, you probably have stickers if you came and sat at the front early in the break. There will be more stickers at the Birds of a Feather session at 12:20 as well. Any other general questions?
I actually have one.
Yes.
Why is it? Why are the ranges 2 dots in the loops and 3 dots in the match statements?
If I recall correctly from having skimmed the docs a few times on that recently, is because there's inclusive and not inclusive ranges.
So the loop of 1 dot dot 100 is either 0 to 99 or 1 to 99 or something like that.
2 dots is exclusive at the end.
Yes, I read the docs on this yesterday by chance. 2 dots is exclusive at the end, 3 dots is inclusive of the end.
That seems like a good opportunity for underhandedness. It does.
Yes, it does. If you can use that to scrape credit card data, then you should enter the competition. That's... Okay, and that is just about the time when I will let you hop out for 10 minutes if you desire a bit of a break, and then come back here at 35 past, and we will talk about ownership and borrowing, types and traits, and how to get involved with Rust. We can resume the recording if you'd like. So now that we are back from our brief commercial and/or human break, we are back to Rust 101, where we have talked about deploying Rust, and we've talked about the basic Rust syntax. You can get these slides at the URL right there, talks.edunham.net/LCA2017/rust101.pdf. They have a variety of links in them, and you may want to refer back to them in the future. So I would recommend noting that URL, as the PDF will live there for as long as I own my domain. Excellent. It has been tweeted with the hashtag, so if you check out the LCA 2017 hashtag, you will find that link. You can also look at my Twitter, which is in the sidebar, and also find that link. So let's jump right back into it with talking about traits and types. When I told you that function signatures are basically Mad Libs, I said, you put a type there. I'll use I32 as an example. Don't worry about it. We'll get to that. Now let's worry about it a little. So traits and types both describe characteristics of things in your program. You care most about these characteristics when they're the inputs and outputs of some operation. They're the interfaces between various parts of your code. We care about what type a given value is because that helps us avoid wasting space. Why would we need 32 bits worth of space if we only have like an 8-bit value? That's just wasteful. And when the compiler is trying to prove that your program won't misuse memory at any point in its operation, we need to know exactly what memory is going to be used when. So the final useful part of traits and types is that they remind humans how their code works. I mentioned that you need to specify all of the types of your function signature, regardless of whether the compiler could have figured it out, because that's a piece of documentation for everyone else who ever wants to invoke or modify your function. So a type describes a single value and tells you some things about it. There are a variety of types built into Rust. The integer that I was using before is an example. There's the various primitives that can hold a value. There are built-in array types, string types, and tuple types as well. Now, the docs will also tell you about slices into an array, which I would recommend not worrying too much about until you're comfortable with the ownership model that we will talk about when we discuss how Rust enforces safety in a few minutes. You can also, of course, create custom types. And the way that you will go forth with making a custom type is either by making a struct or an enum. And the final way that you can get a type, if it's not built in and you're not making it yourself, is you might have inherited it from a dependency. So a type describes one particular value, or what you're going to put in one particular variable. And a trait describes some attribute that several types might have in common. So I think of it as they describe the skills or abilities that a type has. So for instance, all number types, all of the floats, all of the ints, you can add them all. So there's a trait called add that each one of them has implemented for it. And when you're playing around with new types or teaching Rust to combine existing types in new ways, you can give a type a new trait, a new skill, the way I think of it, by implementing it. You do this with impl. And then that tells it, for the given trait, what should I do if someone asks me to use this trait? What do I do with myself and any other value that's involved in the operation that this trait describes? So traits allow you to generalize a function's input and output. I'm not going to go too deep into types and traits here, other than telling you what they are, because the details of using them correctly are quite complex, and they are better documented in the book and the various examples that I will point you at than anyone could hope to do justice in the time frame that we have available. So any questions at the high level about this type system thing? Nope, cool. I did not give you enough specific problems to have specific problems with. That was basically the intent of this section. Because the other really mind-bending thing that you're going to need to be much more familiar with to get some Rust code working than just putting in the right magic numbers into the types when you make a function is the safety models. The core of safety is ownership. When I was describing code before the break, I said we use let to create a variable, we give it a name, and now it owns that value that we set it equal to. So in this example, my int, that string, is the variable binding, and the value of 42 is owned by that binding. So every value has exactly one owner at any point in time. You can give it away. You can change the owner of a given value, but there will only ever be one at a time. If you own a value, and then you give that value away somewhere else, and it didn't get copied, occasionally with very simple values, they might be copied instead of moved, then you can't use it anymore from the previous owner. So you actually kind of, oh yes, and if you want to change something, the owner can change it if it has been declared as mutable. So if we wanted to be able to change what myint stores, we would tell Rust so right when we're creating it by saying let mute myint equals 42, or let mut, depending on which compiler author you listen to. I believe that both are correct. So here we go. Let's make an int. It'll be the first. It's owned by the first binding. We can print that out, and we have access to it. Then if we give it away to the variable binding named second, we can access it by using second. Now, if we had done this with a more complex thing that wasn't a copy type, you would get all kinds of errors if you tried to then use the contents of first. Compiler is quite clever and may copy the value because it knows that integers are cheap to store. So let's say that we need to access a piece of memory from more than one place at once. Gosh, who would ever want to do that? Borrows allow you to grant temporary access to a value, and those borrows can never outlive the owner. There's still one binding that you can prove is responsible for that value. It's just kind of sharing it with some others for a little bit. And your options with borrows are that you can have one mutable borrow to a given piece of data, to a given value, or you can have as many immutable borrows as you want. You cannot both read and write, or you cannot have the ability to both read and write the same piece of memory or the same value at the same time. And if you have fought with multi-threading in a systems language that says, oh, here are the rules, be smart about memory management, you might have realized that most parallelism problems are around that area of, oops, that changed at a time I wasn't expecting it to, and I read it. So the syntax to borrow a value is ampersand value name. And there are splendid examples in the book that show you times when you would actually want to borrow something rather than something tiny and contrived and stuffed on a small projector to confuse you. So the other main mind-bending rule about ownership and borrowing is lifetimes. You will probably meet lifetime errors the first few times you try to play with borrowing a value. And this is because the owner will lose its value, everything will go away at the end of the owner's scope. So if you take a borrow and you try to keep borrowing or referencing back to some value, and that value has gone away because its scope ended, we will notice that at compile time and it won't compile. Rather than finding out as you're running your code, oops, I tried to use a value that wasn't there. I wonder what was there instead. So again, the key points here are that anything that goes out of scope is no longer available to you. It's gone. The compiler will do whatever it feels like with it, which can vary depending on the optimizations that you're using. But no borrow may ever outlive the thing that owns what it was borrowing. So questions about the principles of safety in Rust. If you would like to create yourself some questions about the principles of safety in Rust, pull up something like the book on references and borrowing, and then hit the little run button by one of the examples. And then change a couple things and wonder why you managed to break it. And the first thing to do, obviously, there is to read the error. It will tell you which rule you broke. And it will probably link you to the docs on that rule. And then you will probably stare at the rule and go, oh, OK, I finally see what I did wrong. And then you'll go fix it. So Yes, question there? Sorry, I've got to really put my microphone runner through his paces. Big room, frequent question sections.
Thanks. Yes. You mentioned that sometimes the compiler says, oh, it's cheap to copy an integer, so I'll just copy it.
Yes.
Is that likely to cause confusion or change over time, that things that were easily copied no longer are, and break things, or things that aren't easily copied, things become easier to copy and the compiler decides to just copy them?
Excellent question. This is actually implemented with, is it a copy type? Does it have that trait? If it has that trait, you copy it. If it does not have that trait, you do not. So if we were to add things or remove those things from having that trait in the standard library, it might cause some confusion. But if we attempted to do that or accidentally did that between a couple of stable releases, then Crater would suddenly spew problems everywhere. It would say, wait, that thing that used to work doesn't work anymore. And we would go, oops, yeah, let's not do that.
Can you create your own copy types?
Yes. You can implement the trait copy for a type that you want to, and then that type will be copy. Whether that's a good idea requires extensive knowledge about the exact hardware that you're running on. Cool, so...
I've got a question
yes,
too.
another question.
How does that work with constants? Like you showed that example with 42. What if I want to have two things that share the value 42?
So how does it work with constants? Long story short, if Rust knows that you have a constant that's never going to change, such as if you didn't declare it as mutable, it will use a different section of memory to store it than where it will store mutable values. It's the stack heap thing. And you can tell Rust that you want it to be mutable. You can, if you know you're never going to change it, then you will probably just borrow it immutably. It depends on the way that your program is set up, how you will handle those constants throughout. Yeah?
So I just put that example in where you said it would throw an error into the playground, and it allowed me to...
It failed to throw an error because it copied the value because we used an int, yes. If we used, I believe if we used a mutable int, it would throw an error. But I didn't really want to dump a fancy enum into it. We have commentary? It works with mutable as well because copy is a fantastic trait that will prevent your examples from being as simple as you would like them to. I apologize for not dumping in something sufficiently complex that you would go, why the heck did you create that way? Poor example choice on my part, and I will fix the slides in the future. Yes?
There's a bug in your slide. The one you said should error doesn't actually error.
Yes, we are discussing that.
Oh, shit, sorry. We were too busy going, oh, it's not working.
You were engrossed in the awesomeness of the playpen, which is excellent, and I made the wrong call in trying to simplify the example versus providing the actual error message that you would need. So with that, I will shove slides up with an example that actually does error shortly after this. And let's talk about that library stuff that I promised you. So the package manager for Rust is named cargo, and the libraries are named crates. The package index lives on the web at crates.io. A common question about crates.io is, could we do the Leftpad thing, where somebody gets angry and takes something down, and then everyone who depended on it breaks? Long story short, no. You can publish a crate, and then it goes into an S3 bucket that about 3 to 4 humans on the planet have access to. And then you can mark it as, please don't use this anymore if you're deprecating it, but you cannot actually take it down. If there were a legal problem that somebody said, hey, you need to take this thing down because copyright or problematic content or what have you, if it were a code of conduct violation, we'd be just like, oh, okay, yeah. And we would work with the dependencies before deleting it to replace it with something, although I doubt that people would be intentionally depending on like a code of conduct violation anyways. And if it were a legal or copyright matter, it would be escalated to the appropriate people who know the ins and outs of copyright, and we would have a very clear explanation of why it was being removed and a story for what to replace it with. So long story short, no, we're not going to do the Leftpad thing. There will also be a talk on package managers all the way down, as I previously mentioned, 340 today up there in Tasman B. And the crates.io guide has most of what you need to know about how to use crates.io. The bits that you really care about are when you're starting a new project locally, use Cargo. Use our package manager to start your project because it will put the files in the right places and it will make it trivially easy to publish later on when you decide that your work is in a state that you're ready to share with the world. So the first question that you run into when you're making a project is, am I making a binary? Am I making a thing that we're just going to run and it's going to be my program? Or are we making a library for other programs to depend upon? You're probably making a binary if you're just saying hello world or solving a problem. So that'll be cargo new --bin. And that'll give you a main.rs in your source directory that you'll run to run the main function. And in a binary, every time you successfully build your project, Cargo will update a file called cargo.lock with every detail of how it got that successful build, everything about the versions of your dependencies that it used. So if you want somebody else to be able to run your project in exactly the same way that you did with the exact same dependency versions, they can use that cargo.lock. Now, if you're making a library, you will not include that because Cargo is going to worry about your dependencies when you build it. So you'll just get that source lib.rs, and it's not really sensible for a library to make main, because why would you run a library as an application? Yes?
The lock file,
Yes.
Into Git or not?
Depends on your circumstances. Committing them is useful in that it helps people diff their environment against the environment in which you successfully built it. It helps people troubleshoot. And people can use it to force a matching compilation. So if you really, really hate lock files and want people to just figure it out for themselves, you can leave it out, but it's helpful to leave it in. So when you, yes, another question.
How easy is it for someone to run their own crate host?
How easy is it for someone to run their own crate host? Not easy right now, unfortunately. The source code to crates.io is all public. You could try to mirror the crates.io and then run the web front end to it if you wanted to. If you're working on that, hop into the Rest Tools channel on Mozilla IRC, and we'll see if there's a better way we can get you the gigs and gigs of crate information out of our S3 than just forcing you to download it all. It's generally not a use case that's been needed all that much yet, although there's more and more demand for Cargo working easily behind a firewall and caching crates behind a firewall in controlled environments as Rest gets more and more adoption. So basically, you can kind of fake it and just throw up a copy and hope for the best, but we are working on having a much cleaner story for the real-life applications of doing that. So when you tell it Cargo new, binary or library, you're going to get three things. You're going to get a cargo.toml, which describes the project's dependencies and the project's metadata. You're going to get a source directory containing a main.rs or a lib.rs, depending on whether it's a binary or a library. And if you hadn't already initialized the Git repo, by default, you're going to get Git initialized in this directory, because you should be tracking your changes. If you can't use Git for whatever reason and would prefer to attempt to make it work with another version control system, you can override that option. So you've got your project. How do you bring in a dependency to use someone else's work and save yourself a bunch of time? To depend on a crate, first you need to find the crate that you want to depend on, which is a story that we're working on improving the simplicity of figuring out which of the 3 or 4 competing crates is the best for your needs. However, right now, you'd search crates.io for the general term that you're looking for a crate that does it. You can look at their repositories, look at any website that they have, and use your personal standards for assessing the health of an open source community to determine whether it's alive, whether it's as actively developed as you want, and so forth. And I always search the web. I searched for recent blogs about that crate, because if someone has a really good experience using a crate, they'll often blog about it. And if somebody has a troublesome experience, that'll often show up in either a blog or an issue tracker as well. So check through the docs to make sure it has as much docs as you want. Check that the license will be compatible with your project's license. Again, please license your code. And make sure that the project policies and workflow are going to work for you. And once you've found that crate that seems to meet your needs, you can add it to the dependencies section of that cargo.toml. And you can either specify it by name if it lives on crates.io and then ask for the version. And in that case, Cargo will just go to crates.io, find the crate by that name, pull down the version that you specified if it can, or yell at you if that version is not there. Or you can specify a Git dependency, in which case you say, we're going to use this Git repo optionally at that particular revision. This is very good for dependency pinning. If you are at all concerned about potential security of crates.io, then this is easier to justify to the security-minded people on your team. And if you are engaging in the underhanded Rust competition and you want to inject a problem into an upstream dependency, please fork it and git depend on it. That's the right way of doing this. And then in your file from which you want to use that crate, probably main.rs before your project has gotten any bigger, you will say extern crate and then the crate name that you installed. And then you will say use whatever type out of it that you wanted to get out of that crate. So usually that'll be 2 lines when you're not on slides. And after that, you can just continue using it as if it was created in your code. So any questions about crates and libraries so far? Yes?
What's the best way for tracking security vulnerabilities in libraries that you're using to help keep your program secure?
That is a really good question, and we don't have a centralized source of truth for that kind of thing. If it's a large crate that has a mailing list, sign up for that. If they release new versions, you can try and depend on latest, although that may frequently break your project. So basically, as far as I know, the state of the art right now is checking those dependencies, and when they've updated, see why. Follow them on GitHub, get notified about issues if they tag their issues for that release. And that is a really good point that we do need better tooling for that. Anything? Yes?
Is Cargo inherently linked to Rust, or could you use it for another language? Or particularly if you had a cross-language linkage library, that sort of thing?
You can tell Cargo an arbitrary build script of here's how you build that particular dependency. So people do use other languages in their crates, for instance, a wrapper around a library. The best way to figure out the exact details on that would be to find a popular wrapper library on crates.io and check out what they've done there.
Right, I was also thinking about the other direction.
Oh yeah, the other direction.
A Rust library in C, say.
Sticking Rust into C. I would actually recommend the talk Friday 1:20 p.m. on porting to Rust. I think they might actually be state of the art in terms of linking easily between C and Rust. My knowledge there is that you can do it. Cargo can do arbitrary things when you tell it to build, so maybe that's invoke this make file and build the C stuff. But it is definitely designed with Rust in mind. Like, I wouldn't recommend trying to port, let's say, the Python package index to Cargo. Yes?
Can Rust dynamically load libraries that you've compiled from crates?
Can we dynamically load libraries from crates? So like, if you change a crate, then it will load during runtime. I don't actually know that off the top of my head, sorry. Anybody else here know that? Nope, not a volunteer, but a next question.
Do you ever have a problem where you are relying on a specific library and there's another crate that you're using that also uses that library, but the versions are incompatible. So the crate you're using depends on another crate that's at a specific version, but you need a feature that's in a new one. And if so, how do you deal with that?
Cargo will compile the right version when making each crate's dependencies. And so you might have two versions sitting around, one of which is used by the one thing and the other of which is used by the other. And if everything else works, then you're good. OK, so let's move on to, if you think that Rust is cool, if you think that Rust is something that you'd like to get more involved with, how do we make Rust a better place? How do you level up at Rust? How do you find your Rust project? And how do you get involved with the language and ecosystem itself? So the usual caveats to open source involvement apply. Make sure you check the other people's licenses and respect them. Don't assume that publicly posted code is licensed for reuse in any particular way, because just posting it publicly isn't a license. So please license your own code. And if you ever use other people's blog posts saying, whoops, I did something silly to get this error, here's how I fixed it, please make your own of those when you don't find a useful one when you're looking around. That's part of what makes the ecosystem great. And the caveat to using other people's error experiences and problems with Rust is that it has been moving very quickly, especially before 1.0 hit. So double check the date on any resource that you read. You'll find posts from like 2012, 2013 talking about there being green threads and attempted GC in Rust, and you'll go, what? I didn't think it had that. And no, it doesn't have that today, but it went through some interesting phases in its youth. If you learn and level up by reading books, there are good books out there. The usual book, the Rust book that No Starch has been publishing a version of that Steve Klabnik wrote, is kind of Rust for Rubyists. It is a great intro to the language, although it doesn't dive as in depth as some existing systems programmers would like into the way that Rust works under the hood. It's a great place to start. Then if you want to dig around in advanced and unsafe Rust programming, there is the Rustonomicon, which is one of the compiler author's personal views on how the heck is the right way to do this and what's available to you. It's a delightful read. He has a very engaging writing voice, so that's a fun one. And then coming out, I hear it sometime this year, although I would probably get in trouble if I said that on a recording like I just did. There is an O'Reilly book on the way, which is going to be the reference that I recommend for people coming from a hardcore systems background who want to know all of the details of, wait, what memory is it allocating and why is it doing that when I call this function? So if you would like to follow the news about Rust, there's a podcast called New Rustation that tracks Chris Kreitschow's experiences leveling up on Rust and is generally, I think, a weekly thing. It can be a good listen, and he provides example code with it. There's also Rusty Radio, that's a variety of interviews on Rust. Then, if you like reading blogs and updates, This Week in Rust is a weekly blog saying what changed since the last time we posted this, what cool new developments are happening, what requests for comment landed and are going to be incoming on nightly as new features, and so forth. And then the official blog announces all of the really important stuff. To practice your Rust, there are a couple of places that I would go first. Carol's 10 Cents published a repo called Rustlings, which are simple examples where she'll give you a challenge, tell you what to do with it, and then if you scroll way down the page, she'll give you the solution. So those are quite good exercises. There's also the Rust by Example book, if you learn best from looking at simple example code. So questions about where to go on your own journey into Rust at the moment? Yes? Don't apologize.
Anyone else want to go first?
No, ask the question.
I'm terribly sorry. So I'm sort of madly clicking around here. One of the things I'd like to do is I was just thinking, I'd like to write like a multicast listener or something in Rust. So I was trying to find where's the socket code, and I honestly, I've spent a good 3 minutes trying to find it. Where am I not looking?
I would check arewewebyet.com for a variety of, so I heard you liked writing servers. Here is what we have available. You will probably depend on either Mio or someone else's wrappers around Mio. MIO is the missing IO library, which is not in fact missing at all because it is very present, very robust, and very well supported. It really depends on what amount of abstraction you're looking for there. And you can also dig around on crates.io for someone else who uses sockets and just be like, how did you do that? Those are the approaches that I would take. Yes.
Hi. Can you point out what the state is of Rust for embedded, and if there's any kind of thing that's the canonical, this is the most supported device or architecture for embedded devices?
Yeah, Rust for embedded is in an interesting state in that embedded is explicitly one of the places that system languages shine, and yet we don't have a whole lot of consistent support from people in the embedded community on fixing Rust for whatever device every single time it breaks. We'll target ARM, but then we won't target weird problems that you have on teeny tiny little ARM board, for instance. You will find examples of Rust for embedded platforms. There's quite a bit of Raspberry Pi stuff. Pretty much any board that LLVM supports, it's quite likely that someone will have gotten Rust up and running at some point and blogged about it. It's also quite likely that at the end of the weekend, they will have said, OK, that was fun. Stick it on GitHub. On to the next new adventure. So it's the state of current support will vary somewhat depending on what platform you've picked. And I believe that the Redox project, the operating system that's being written in Rust, actually targets smaller computers. And so generally, find a recent blog post by someone who says, hey, look, I made it work on my Pi. See what they did. Follow their steps. And then if you'd like to contribute, support keeping that up to date as the language changes is absolutely fantastic. Yes.
I'm just wondering where Rust doesn't run. Like I'm on the Samba project and I'd like to use it in Samba. Is there anywhere that I would expect to find Samba that I might have trouble getting Rust to run? I mean, we still have people trying to run Samba on HPUX.
Yeah, again, the LLVM support list is pretty much the places where it's easy to get Rust up and running list. The most recent place Rust doesn't run that I've met was actually the ESP32 board at the Open Hardware session, because too new for LLVM, so nope. There are, I don't actually recall the platforms off the top of my head, but a variety of companies who need to support obscure old hardware have challenges with Rust because there's that one person on that one really old system that Rust cannot target yet, and we can't leave them behind. So, yeah, it's all good. I can repeat that partial answer if you like.
I just said LLVM is now doing ARM64, which was the last sort of really hard thing they were doing.
Ah, yes. LLVM now supports ARM64, so the places Rust won't run are now fewer than ever. Such a helpful answer, I know. So we are doing pretty well on time, and I will be able to get through how we find a project and how to get more involved. So you want to find a Rust project to hack on. You could just look up a popular crate on crates.io and see what easy issues they have open. This will vary in its success wildly from crate to crate. Some have a very active moderation team who files their easy issues and tags their easy issues and saves them for newcomers. Others are totally swamped and don't really have the bandwidth to bring you up to speed. You can more reliably find unloved little Rust projects that nevertheless need more hands by searching on GitHub for, it is an issue, it's labeled easy, and it's in the language Rust. If you then add a date filter for it had activity on it within the past 2 or 3 months, you will find quite a few little active projects that are looking for more people. If they're bothering to label their issues easy, that means that they almost certainly have someone who's willing to help mentor you through and get you up to speed on contributing to that project. Another way to get involved is to try and port something to Rust and see what happens. If you learn best by diving in and getting your hands dirty, this might be the option for you. Jamie Sharp has written a tool called Corrode, which, as we mentioned at the start, kind of sort of ports CVS to Rust in a way that is no worse and no less safe than the original C was, although one could discuss what kind of claim that is. As I have been plugging throughout the talk, the session on Friday at 1:20 in Tasman B talks about another option for porting to Rust when Corrode won't meet your needs. And you can incrementally add more and more bits of an existing program to Rust using that program's foreign function interface support as described on the Rust blog. So any questions about how the heck do I even find a Rust project to get involved with? Of course, the one that didn't make the slide because it is so obvious is that you could just start something from scratch if you have a dream project. Any questions about how to find an existing one? Nope, awesome. We will have some amount of project matchmaking also at the Birds of a Feather session, which will be in here during lunchtime immediately after this talk. One of my jobs is, could you bring the microphone up? One of my jobs as community team is to find the people who are looking for group, find the groups that are looking for people. Question?
You have a cool new idea and you want to write your library. How do you claim namespace?
Yeah.
Who has the right to the name?
You make sure you're not stealing it from some other project by Googling around a little. Pretty please Google your name on its own to see what you get. If you get a lot of things that are unrelated to your project, please make your name a little more unique for the sake of all users everywhere. And then publish a boilerplate crate to crates.io with that name, and then you own it.
Is there any namespacing or conventions around saying this is something that handles HTTP or this is something that handles email? I should name it in a way that matches email rather than just cool name of my dog.
Honestly, most of that lives in the metadata and on the tags that you stick in that metadata that you can search by tags on crates.io as well. I think you get bonus points for naming it something witty related to either chemical Rust processes, maybe Trust if you're a security crate, or those cool little fungi. Those seem to be popular, although really name it something unique and easy to search and describe it clearly in its README and in its metadata, and you're good.
Yeah, my experience is coming from CPAN, which has a very structured, you namespace
Yes.
it here if you're this type of
Yes.
thing.
We don't currently even namespace based on user who submitted it. So we are talking about ways that we could improve crates.io without breaking backwards compatibility. Generally, the only time that project leadership might step in is if you're trying to impersonate a more official crate, like Rust official standard library or something, and it's misleading users and making their days unpleasant. I hear whispered under someone's breath, that's what got NPM into trouble. We won't go there. So now let's say that you like Rust, you like the community, and you want to get more involved. How do you start reaching out to the compiler on the hypothetical path to becoming a maintainer yourself, like we discussed in the keynote this morning? Well, the first step is probably to file or fix issues that occur with the language. They're on the GitHub issue tracker, Rustlang Rust. We do try to triage regularly, so don't take it personally if we say, sorry, but that's already filed over there. And if you're in doubt about whether the thing you've encountered really is a bug, just ask on IRC. We're friendly. If someone is unfriendly, they will be stopped promptly. So chat online with people who like the project and people who run the project. The IRC channels, which are officially moderated by the mod team, are Rust beginners. There are a variety of team channels like Rust-community, Rust-tools, Rust-internals for the compiler dev work. Please don't ask your user questions on internals. It slows everything down and you have a less awesome Rust as a result. Instead of a mailing list, because we need to be able to moderate well and remove any problematic posts, we use a discourse forum that lives at users.rustlang.org. You might sometimes find information on internals.rustlang.org. Again, please take your user questions to users and not internals, because mixing those two will slow development down and give you a less awesome Rust. And we have a variety of side channels that the mod team will make an effort to moderate, but we provide no guarantees because there are just so many of them. A couple of the bigger ones are Reddit and Stack Overflow. So our Rust on Reddit is the Rust programming language. Our Play Rust is the game. You should look around if you like interacting with humans, which I assume you might because you're here at a conference, for a meetup in your area. So doing a web search for the name of your area and Rust meetup will often get you something. If that doesn't, check out the Rust community team calendar, which I have short-linked you there. And we try to keep track of when and where all of the various meetups are happening, because they all use different software depending on where they are. And the Rust community channel on Mozilla IRC, irc.mozilla.org, is a great place to meet the community team members. Say, hey, I'm thinking about starting a meetup in such and such a region. What should I do? Is there anyone else who's expressed interest in this? And so forth. And we can be kind of a central switchboard of everybody who wants to lead more involvement. And if you like attending conferences, there are a variety of them. Last year, we had RustConf, Rust Built Rust, and Rust Fest in various parts of the world. I don't know of a Southern Hemisphere Rust conference yet, although if any of you are really big fans of conferences, that can be easily changed. So those are the links to keep an eye out for and see when their CFPs come around or join their mailing lists. So any questions about getting more involved in the world of Rust? Nothing right now. That's good because we are rapidly approaching time. My last piece of information for you is that we are having the Rust Birds of a Feather session right here after you've gone and gotten your lunches. So that will be the time to start hacking, run into funny problems, ask about the funny problems to the other people who enjoy using this language. So thank you all very much for coming and learning things, and I wish you a successful journey into the world of Rust.